Okay, in this video I plan on showing you the difference between proportional and non-proportional. We're talking linear. And so I just want to kind of show you the two things, the things that you look for. Okay, so let's talk about the first one, which is easiest, is a graph. Alright, so on a graph, on a proportional and non-proportional, okay, and I'm just, like this is just very, and I know I mentioned this before. Okay, on a graph, the proportional starts at the origin. It's always at the origin, so the line will always go, and that's the origin right there, 0, 0. It always goes from the origin there. But on a non-proportional, all right, on a non-proportional, it starts somewhere else other than the origin, and it can be anywhere on that y-axis. All right, it could start somewhere right here and go this way. Notice the difference in the two, where one starts at the origin, one doesn't start at the origin, it starts anywhere. Now remember, just so you understand this, it can start, if we have a y-axis that extends in the negative, all right, it can even be somewhere, it can be anywhere on this axis, this y-axis, except for 0. All right, except for 0. All right, but it can be anywhere. That line can start anywhere except for 0. If it starts on 0 and you have a constant rate, it will be proportional. If you start at y-intercept and you have a rate, it's going to be non-proportional. Okay, so those are the two differences in those situations. Let's talk about the equation. All right. In the equation, you have proportional is usually y equals kx, direct variation or direct proportional. In a non-proportional situation, you'd have y equals mx plus b. Now, really, these are the same. The only thing they did was they changed k and the m, but there really is a b here. It's just we know it's 0 because of the origin. B represents the y-intercept. Okay, so it's our starting point. So if our starting point is 0, then we're not going to have anything there. It'll just be k and x. And then on the non-proportional side, if you have a y-intercept, it's going to be where that y-intercept is. So like in this situation, I could have a 3 there because of where my line starts. Both of these, I do want to point out that the k and the m represent the same thing, basically. I mean, they really are. They're both the slope. I mean, there's no arguing that. It is still the slope. One, that's the main, basically the same thing. The only thing different between the two is where it starts the y-intercept. All right. So we talked about a graph, and we talked about the equation, how they differ. All right. Now, okay. So now that we've done, like I said, a graph, now we're going to do a table. So if I had a table here, what would I be looking for? So let's pretend we have a table here. All right, and we're going to basically make the same thing, except we're going to change one thing, of course. All right. So when we're looking at a table, we're looking at a constant of proportionality. So like. Let's say that let's say that we say 1, 2, 3, 4. All right, and we say 5, 10, 15, 20. All right. In this case, I'm going to say 1, 2, 3, 4. All right, and I'm going to say. Let's see, 8, 13, 18, and 23. Okay, so in these two situations, we're looking to see we're going to try to see if we can find out which one's direct and which one's, proportional and which one's not. So if we're looking at a table, the first thing I want to do is I want to probably try my k equals y over x. And if I do this for each one of these, remember y is on be 10 over 2, which is 5 over 1. 15 over 3, which is 5 over 1. I can also go backwards, look 4, 3, 2, 1, 0, and then I'm going up by 5s here. So I know my K, my constant, is still the same. Okay? I know that's still the same. So K does help here. K equals Y over X. And I'm going to write this again so you can see it. 15 over 3 is 5. And that's 5 for all of them. So these are going up by 5s. And if I go backwards, I'm going to subtract 5 from there. So 5 minus 5 is 0. So that would be 0. So you can see that is a direct variation. It's proportional. If I look on the other side, I can see that if I did 8, my K, 8 over 1, okay, but then the next one I do 13 over 2, which is 6.5. See how they're different? And then 8 divided by 3 is 6. So none of these K's are the same, where if I did the K on the other one, they were all the same. All right, so there's one. That's another way you could look at it. You could look at just looking for the K, and you can see the K's are not, it's not proportional. Otherwise, they're not constant. K's not constant. Now, if I did look at this, I could do the 4, 3, 2, 1, 0 thing, and these look like they're going up by 5s as well. They're all going up 5s. But if I take 8 minus 5, I get 3. And so, see, right here shows that I have one at 0, 0, the other one at 0, 3. So this one would be a non-proportional one when you're looking at a table. All right? So those are the main things. Now, the big thing is if you're reading a word problem. If you're reading a word problem and you see something that says a service fee or initial or original, and then they tell you the slope, that is non-proportional. If they just tell you like, let me give you an example on these two tables here. So let's say I look at the table on the left here. That's this little table right here. Let's say that pizzas are selling for $5 each. All right. Well, if you don't buy any pizzas, you don't pay anything. I mean, that's how the table works. One pizza, $5. Two pizzas, $10. Three pizzas, $15. Four, $20. Let's say on the other side, let's say that it's $3. Let's say it's $3 initial fee for. Okay, let's say you're going to get a Coke, and you just want one Coke, and that's $3. But you want to buy lots of pizzas. All right, so you buy one pizza, they're $5 each. So again, if you bought a Coke and you bought one pizza, that's $8 because the Coke was $3 and you didn't buy any pizzas. You just bought a Coke. All right, and then and like I said, you bought one pizza, that's $5. So 5 plus 3 is 8. If you bought two pizzas, they're both $5. That's 10. But you also have a Coke, which is another $13. So I hope these two examples were helpful.